So lastly, we'll be getting into problem 3. This is going to be a similar concept as problem 2, but we've got a different kind of equation here. So first up, we are going to have to isolate our y variable on this top equation here. So we have 2y minus 1 is equal to 3x. So we're going to isolate the y variable by going to y is equal to 3x plus 1. Then we'll have to divide both sides by 2 to get y is equal to 3x plus 1 divided by 2. So here we're doing substitution, and we're going to substitute in this y value here that we have found into our second equation for y here. So we're going to have x squared minus 4x plus 3x plus 1 over 2 squared is equal to 0. So then we're going to have to square this expression out to get x squared minus 4x plus 9x squared plus 6x plus 1 over 4. Remember, because we're squaring the entire expression, that means numerator and denominator. And then we're going to have to simplify this all by multiplying out both sides by 4. Multiply both sides by 4. So we're going to have 4x squared minus 16x plus 9x squared plus 6x plus 1 is equal to 0. And then we're going to simplify this. So we have 4x squared plus 9x squared. We have negative 16x plus 6x. So that is going to simplify down into 13x squared minus 10x plus 1 is equal to 0. We're going to have here then x is equal to, or we're going to incorporate our quadratic formula, negative b plus or minus the square root of b squared minus 4ac over 2a. Our b is negative 10, our a is 13, and our c is 1. So we're going to have 10 plus or minus the square root of negative 10 squared minus 4 times 13 times 1 over 2 times 13 is going to get us, and then if we simplify that, we're going to get x equals 10 plus or minus the square root of 100 minus 52 over 26, which is equal to 10 plus or minus the square root of 48 over 26. So if we plug this into our equation to find our solutions for x, we're going to get x is equal to 0.65 and 0.12. And then if we plug these values of 0.65 and 0.12 back up into our equation here of y is equal to 3x plus 1 over 2, of course, we're going to plug those in up there. And when we plug those in, we're going to get y is equal to 1.45 when x is equal to 0.65. And when x is equal to 0.12, we're going to get y is equal to 0.68. So our solution is going to be the ordered pair 0.65 comma 1.45 and 0.12 comma 0.68. Again, we're going to have to verify this graphically. This top equation here, 2y minus 1 is equal to 3x. That's going to be super easy to graph. We'll just see, we have it isolated already of y is equal to 3x plus 1. So, over 2, I mean, of course. So if we plug in some x values here at 0, we're going to have 1/2. At 1, we're going to be at 2. At -1, we will be at -1. So we can see this is a graph with a y-intercept of positive 1/2, and the slope is going to be positive 3 over 2. So, very simple line there. There we go. That's somewhat accurate. All right, and then next we're going to have a circle graph here. The x squared minus 4x plus y squared is equal to 0. And that is going to have its center at 2, 0. And it's going to have a radius of 2. So we're going to have points at 2, 2, 2, -2, 4, 0, and 0, 0. That can be found just by plugging in as well, if you choose to just plug in values to find your graph. If we draw out a rough sketch of our graph here, we can see it's going to intersect the other line roughly right at the point of 0.12, 0.68 here, and roughly at 0.65, 1.45 here. So just by sketching that out, we can see clearly that our solution set here that we found is indeed accurate and the graph matches up with it. And that is how to solve problem 3.